Hey, what do you know about percentages? I guess you've done some calculation or you hear the word percentages quite a bit. Have a look around at the green pieces on the screen and there might be an answer there for you. Let's go up here to this top one. Okay, there's one little green dude down this end, come down this end. And I guess you would know how many little squares there are there. There are actually 100. And that's one little dude out of 100. What about this down here? 50 squares, out of 100. And this one here, 25 squares out of 100. And this one, they're all shaded, it's 100 squares out of 100. And you're starting to get the idea of what a percent is. Well, we'll have a look in a minute, but we want to get up close and personal with percentages here. Not just do a lot of calculations, but see how they're useful and why we use them. Okay, so around the screen also are some fractions. These fractions are very much like each other. 8 out of 13 or 7 out of 12, 5 out of 9. Which one's larger? Would you like 8/13 of the big pizza pie or 7/12? What do you think? Well, we're going to come and have a look at that now and see if we can get up close and personal with percentages, because maths is fun if you really know what's going on. Okay, we're going to start with the meaning of a fraction. The fraction 3/5 means 3 out of every 5. 8/13, both of these fractions were on that first screen, means 8 out of every 13. Ooh, very hard to compare, isn't it? You could say, oh, honey, I'll just go and put it on the calculator, mate, and make it a decimal and see which one's bigger. No, you're a budding young mathematician. What we've got to do now is actually work it out mathematically so we really understand what's going on there. So 3 out of every 5 or 8 out of every 13, which is bigger? Okay, so we could do something like this. You've done lowest common multiples and you've got 3/5 compared with 8 over 13. You could change them both to a common denominator, which would be the lowest common multiple. Oh, do you remember that stuff? Got to remember the old stuff because math builds up in a sequence and you've got to accumulate knowledge, sequential and cumulative. So 5 times 13 is 65. So we could convert both of those to 65ths. So what have I done to 5? I've times it by 13. So I've got to do the same to the top line to keep the meaning or the balance of the fraction the same. So 3/13 is 39, and 13 has been times by 5 to get 65. Got to do the same to the top line, so that's 40. Ooh, they are very close, aren't they? But 8/13 wins by 1/65. Okay, so it can be done. But hey, I've got a whole set of fractions up on that first screen. Do we have to keep doing it? Because all the common denominators wouldn't necessarily be the same. So, what could we do to compare fractions? Well, you know, don't you? You know what the unit's about here, and it's about changing them all to percentages. Okay. What is the meaning of percent there in blue? Well, it comes from the Latin per centum, or per hundred, or for every 100, how many do you get? So we're going to use what? A common denominator, which is not a common multiple of the denominators of any fraction, and we're going to change them all to hundredths to make it easy to compare. And you're going to get excited by this presentation of what you can do, particularly at the end. I've got an interesting little puzzle for you. So let's go and have a look. Over here, 50% means 50 out of every 100. There we have it. And we could say, hey, 50 out of every 100, we could change that to a fraction, just like we did with 3/5. So it's 50 out of or divided by 100. 50 hundredths. 25% means 25 out of every 100. There it is. It's about a quarter, I think. It's exactly a quarter, isn't it? That's 25 out of every 100. So this is the way to go. If we convert everything to a percentage per 100, then we have a comparison we can make. So it's like saying, hey, we want the bottom part of every fraction to be hundredths or percentages per 100. All right, have you got it? I hope you're getting up close and personal with this. I want you to really see it and enjoy it and have fun with it. Okay, let's come down now. and have a look at what we're going to do. Let's change fractions into percentages so that we can what? Compare them. Let's compare them. All right, so come down and let's have a look now. 3/5 means 3 out of every 5. And our question is, how many is that out of 100? Because we want to change everything to a percentage for easy comparison of stuff. And you're going to see it right at the end. I'm going to really scrape this up a bit. There's a good puzzle at the end. You're going to be amazed at the importance of percentages. Okay, so let's do it. 3 out of every 5. How much is that out of 100? Well, let's find 3/5 of 100. Or say, how many 5s go into 100? Or how many times does 5 go into 100? There are 25s in 100. So this would be 60 per 100. 3 in every 5. Let's find how many 5s in 100. 20. So that's 60. 20 lots of 3. 3 in every 5. 20 lots of 5s in 100. So it's 3 by 20 is 60%. That's good if you can understand that. Or at this stage, you might just want to remember the rule. You multiply the fraction by 100. Because if it's 3/5, let's tidy this up a little bit now. Let's tidy this up a bit now. 3/5, 3 out of 5. If you want the same proportion or amount out of 100, let's find 3/5 of 100. So you multiply the fraction by 100 because you want percentum per 100. So there we have it. We have our common unit here now of 60%, which is 60 per 100. And gee, that's a powerful comparing tool, isn't it? Comparison tool. To just see what's going on. Bring it all to amounts out of 100. Do you get it? Okay, come down. We're going to do some stuff now. And here's an example from Hayes and Harris publications. So you should have that book handy by there. Convert these fractions to percentages. And you know why now. So we've got an idea of how big they are compared to each other. So 3/5, make it a percentage, it times by 100, and that's a per 100. So that's the one we did. What about a decimal? 0.042. Now, we want that decimal fraction part of 100. So we'll multiply it by 100. And you could just shift the decimal places. I hope you remember this stuff. Multiplying by 100 is shifting 2 places to the right. So it's 4.2%. Okay, what about a 6? Times 100. There it is. It's a fraction. We could try to divide this. 6 into 100 is 16 2/3. So that would be the exact answer, 16 2/3, which is, of course, 16.6 recurring. So that's approximately, look at that sign, approximately 16.7%. And I like students to write 3SF, 3 significant figures. We'll learn about that later. So when you truncate or round off, let's have a look here. This is really this, isn't it? It keeps going. It's a recurring decimal. So we're going to just use one decimal place or 3 figures, 1, 2, 3. And so this last decimal place, really to represent this number best, it's actually because of this 6 in the next position, it's over halfway towards 7. So we're going to round it and say the 7 is the best measure of 16 2/3 there. All right, we'll come to those figures a bit later on. Let's go down. I want you to do some of these problems now. So here's 5A1. So I think you should do all of these. Okay, so in this work, of course, if you can cancel, you will. Like, let's say, what can we have? 3/20 times 100 to change to a percent. 20s into 100 go 5, so that's 15. Okay, so try to do a bit of work by hand. Don't race to the calculator, because that defeats the whole purpose, isn't it? Doesn't it? Okay, so multiplying all those by 100, remember your shifting of the decimal rule here. Okay, and it might be important to realise that 100% means the whole. 100 out of 100 means the whole lot. The whole. Okay, 100 squares coloured out of 100 is 100%. Okay, and down here, the same sort of stuff. Where you get caught, you'll need to possibly use the calculator there. Here's an interesting one, 0.83 recurring. Okay, remember that 3 recurring is a third, so you might have to be careful with that because they say into exact percentages. Okay, no rounding allowed. All right, how are you going? I'll show you the answers now. Okay, so check your answers and see how you go. Remember question 3, they have to be exact. All right, so you've got a couple of fractions to watch there. All right, let's move on now and see what the next thing is we can do with percentage. We want to ask that question, why use them? And here you are, finding a percentage of a value. Calculate 25% of 80. And they're trying to say things like 25% of the 80 people want to follow football or soccer or basketball, something, rugby. Okay, so what number is that? So we're going to use it around the place quite a bit because it's a universal, if you like, or universal, very good tool for comparisons, comparing fractions and the numbers. Okay, 25% is 25 over 100. Why? Because 25% means 25 per 100. Okay, we've established that, which is equivalent to 25 out of 100. There we have it. That's the idea. And so if we want that fraction of 80, 25 hundredths of 80 is 20. Okay, so 25% of 80 is 20. Well, that's a slightly new language, if you like. A language which is universal between fractions. All right, let's have a look now at another one. Somebody says all the apples were bad, 15% of 200 apples were bad. So the 15% suggests that every load that goes out might be like that. How many of your apples were bad if 15% were bad? So you go 15 out of 100, and you want that fraction of 200. So 15% of 200 would be 30 apples. Notice here we can cancel the noughts there and get 15 times 2, jumping over here. Okay, they've put the 100 underneath that one. Okay, so that you can see quite clearly how to cancel. 30 apples were bad. So you can see it's quite a good way of speaking about things in general now. Okay, let's have a look at 5A2 here. Express these percentages as fractions in lowest terms. Okay, in lowest terms here. So here we've got to divide by 100 and then try to divide top and bottom of the fraction by a common number, or cancelling if you like. Okay, and then these percentages here, same thing. Okay, it's per 100, so our tool is multiplying by 100 because that's what every one of these symbols means, per 100. Okay, so we want to, oops, I put times by 100. Oh, got to divide by 100, silly there. What's that? Per 100 means out of 100, so you've got to divide each of them by 100. All right, so just notice what happens here with 144%, because 100% is the whole. So what do you get at the end of that? Do you understand it? Might discuss that with classmates and your teacher. Let's have a look at the answers now. Okay, there we are, 5A2. You can see what's coming up down there. Let's compare amounts using percentages. And this word compare is one of the crucial reasons why we use percentages. I think we're gradually getting to an answer about why use percentages, aren't we? Here we are. 2 races were being run and rain stopped them or something like that. Mike ran 10 kilometres out of his 50. He was in a longer race. Justin was a bit younger. He ran 7 out of 40 kilometres in a junior race. And then rain stopped the race. So you might say, well, who ran more? What part of their race did they complete? Who ran the greater proportion? of their race. Okay, so how would you do that? Well, of course, you could convert to fractions. Mike ran 10 out of 50. Remember, 10 out of 50 for this division here. And Justin ran 7 out of 40 kilometres. So too hard to compare 40 out of 40 and out of 50 times by 100. And let's compare out of hundreds. And that's, of course, out of hundreds implies percentage. Okay, so this is 20% and Justin was 17.5. So actually Mike ran a little bit more of his race than what Justin did of his. Okay, getting the idea. It's good for comparison, isn't it? Wait till I show you the example at the end. You'll be excited about that. Okay, here we go. Example 4 from Hayes and Harris. Mike ran 10 out of 50, and you can see why we might want to write that as a percentage. There you are, to compare with what proportion he ran of the race compared to somebody else. Rani spent 5 months of the last 2 years overseas, so how much time was spent overseas? 5 months, here's a crucial word. 5 months out of 2 years is 24 months. When you're doing percentages, these units must be the same. So I'll just write that down here. Units must be the same. That's very, very important. You can't compare apples and pears, can you? No, apples and bananas, whatever they say. Units must be the same. So if you've got 5 months, you can't put 2 years here. It's got to be a proportion of the same unit. So 2 years is 24 months. So it's 5 out of 24, and then out of 100, you'll times that fraction by 100 to get a percent. So Rani spent about 20.8% of the last 2 years overseas. All right, and see what we're doing here. We will use 3 figures usually, which amounts to usually 1 decimal place. Okay, and notice the approximate sign in here. Okay. You could put 3 significant figures, indicating that you've rounded this last figure off to get the closest number to represent the actual value. Are you ready? It's your turn now to express as a percentage so that we have a universal language now. So there's quite a few here. I want you to try probably just every other part of this one, or alternate parts, making sure, look out for these units. Okay, kilometres, litres, hours and days, ooh, mixed units there. Okay, so do some of those with mixed units. Okay, pause the presentation, have a go, there's the first 4. Going to do the same as usual. At the end of this little set, I'll show you the answers. Right, come down to the next few problems here. There's 5, sorry, I thought there were a couple more. Okay. So here you are, you can compare those 4 runners. Remember, very handy for comparisons. Percentages, because you're taking everything out, oops, I won't put it on the side there, out of 100. How many out of 100 for comparisons? Okay, let's have a look at the answers now. There they are. I hope getting a few right. You might have to pause the presentation, go back and have another go and just watch what I've done. Okay, let's go down to the puzzle now, and this is exciting, this part. All right, my question for you, and we've got some data on the board there, and this comes from Hayes and Harris Publications, and I want you to sort of think about which sport is more dangerous. Okay, in terms of getting injured. We're not talking about the level of injury, just getting injured. Which sport is more dangerous? There you are. Okay, have a look. Here we are, the injuries, and here's the number of people playing the sport. Okay, what would you say? Have a look. These are numbers only here. In thousands, figures in thousands. So that's all right. This is 246,000, out of 960,000 people playing Australian rules football. What's your reaction? One could say, gee, look at that column of injuries. That's the biggest. Hey, that's the most dangerous sport. But is it? How would we compare? What about some of these little ones down here? What have we got here? What's a little one here? Rugby league. Only 80 injuries. Okay, how would we compare? We can't actually decide from this type of chart. What would you do for a comparison? Oh, there's that word, comparison. We could use percentages. Percentages of what? Let's look at Australian rules football here. There's 246 injuries out of, where is it here? Here it is. I thought that was still the same one. So it's not Australian rules football there. Here is Australian rules football, 492. So it's 246 out of 492. If I change that to a percentage, this is Australian rules. I nearly compared the end one there, which is not, that was cricket. Australian rules is down here for number of people playing. And if we compared it to rugby league over here, we've got to watch these columns. I nearly went the wrong way there. Rugby league is 80 out of how many people playing it? There it is there. 160. Let's compare using percentages. Okay. Now, 246 out of 492 is, it's approximately, 250 out of 5, it's approximately 50%. And so this is exactly 50%. So there's not a lot of difference. So although Australian rules here looks as if far more dangerous, here, rugby league, about, less than half the height, is the same. They're actually the same amount of danger or same number of injuries per 100 people. So we must have a reasonable comparison. And what's a reasonable comparison? Percentage. Let's change both of them, both of their proportions, 80 out of 160 and 246 out of 492. No common denominators, no, that'd be too hard. Change it to a percentage out of 100. And so some of the stuff with statistics where you've got charts like this, you have to be very careful that you don't misread the heights of columns as meaning something that they don't. Okay, so it depends on how many people are playing the sport, and you've got to use something good for comparisons, percentages. All right, what do you think of that? I think if you go back over it, you'll see the real value of percentages and not why you just calculate a whole lot of stuff. Now, you've got to be able to do the calculations, but it's important to get up close and personal and realise that this is a very valuable little bit of mathematics here. So that's all from me now. I'm going to catch you in a couple more presentations on percentage. There's 2 more, so I hope you're excited about that. Cheers for now.